Dear students, Namaste and welcome back to a new mathematics session. In today's session, we shall discuss how to solve transportation problems by using linear programming. Let's move on to the topic. Question number 6 from the miscellaneous exercise. Two godowns A and B have grain capacity of 100 quintals and 50 quintals respectively. They supply to three ration shops D, E and F whose requirements are 60, 50 and 40 quintals respectively. The cost of transportation per quintal from the godowns to the shops are given in the following table. Transportation cost per quintal in rupees from or to. So D to A, the transportation cost, or A to D, the transportation cost is 6 rupees per quintal, means for 1 quintal 6 rupees. From B to D, the transportation cost is 4 rupees per quintal. And A to E, the transportation cost is 3 rupees per quintal. B to E, the transportation cost is 2 rupees. A to F, it is 2.50. And B to F, the transportation cost is 3 rupees per quintal. How should the supplies be transported in order that the transportation cost is minimum? What is the minimum cost? So here this is the transportation cost per quintal, and here we have to find out in which way the supplies should be transported in order that the transportation cost is minimum. So the cost for transportation should be minimum, and what is the minimum cost for transportation? That is what we have to calculate. So let's go through the question once again. Two godowns A and B. There are two godowns A and B, it is mentioning in the question. Have grain capacity of 100 quintals to 50 quintals respectively. 100 quintals for godown A and 50 quintal for godown B. That is a capacity. They supply to three ration shops D, E and F. From A and B, supplies are there to three ration shops D, E and F whose requirements are 60, 50 and 40 quintals respectively. Means 60 for the requirement of D is 60, requirement of shop E is 50 and the requirement of shop F is 40. The cost of transportation per quintal that we have discussed here. So the cost of transportation is mentioned in the table. And by using linear programming, we have to find out how we can supply these quantities or this ration to these ration shops with a minimum cost. And what is the minimum cost? That is what we have to calculate. So let's assume godown A transport X quintals to shop D, because there are two godowns A and B, and from A X quintals it is transporting to shop D. D is our first shop. And from godown A transported Y quintals to shop E. From godown A transporting Y quintals to shop E. This is what our assumption. These two assumptions we have to make, and by connecting these two we have to calculate the other quantities. Now we have explained the conditions given to you in the question. Let's visualize the question. For that, let's take a snapshot of the question here and let's visualize it by using the given conditions. Two godowns A and B. So we have two godowns, godown A and godown B, and they have the grain capacity of 100 quintals and 50 quintals. So the capacity is written. Capacity of godown A is 100 quintals. Capacity of godown B, that is 50 quintals. They supply to three ration shops D, E and F. So there are three ration shops D, E and F whose requirements are 60, 50 and 40 quintals respectively. So here requirement of shop D is 60 quintals, requirement of shop E, that is 50 quintals, and the requirement of shop F, that is 40 quintals. The cost of transportation of the godowns to the shops are given in the following table. So that is given to you here, that we will use later. As per our assumption, that is from godown A, X quintals transported to shop D and Y quintals transported to shop E. That means the capacity of godown A is 100 quintals. Out of 100 quintals, X quintals already gone to D shop and Y quintals already gone to E shop. The balance only will go to F, that is out of 100 X and Y is gone, that is 100 minus of X plus Y quintals, that will come to shop F. Now from B, how the supply will go, that let's check. Shop D is already taken X quintals. Total requirement is 60. Out of that, X quintals already taken from shop A. The balance only they can get from shop B. That is 60 minus X. 60 needed, X is taken. So balance is 60 minus X. Then here from shop B, E will take 50 minus Y because 50 is the requirement, Y already taken. So 50 minus Y they will take from godown B. And from godown B, how much it will go to shop F? Means already F is taken 100 minus X plus Y, and here 40 is the requirement. That means 40 minus 100 minus of X plus Y. Here when you calculate, there is X plus Y minus 60. That we can take from godown B. Now the cost of transportation from the table we can write, that is rupees 6 from A to D, it is written here. Then rupees 3 from A to E, and rupees 2.50 from A to F. Then again rupees 4, that is B to D. Then rupees 2 for B to E charge, and the next is rupees 3 for B to F, the transportation cost. As we know that the number of quintals transported to each depot must be greater than or equal to 0. The transportation from, or the quantity which is transported from each godown to the shop must be greater than or equal to 0. That means here X greater than or equal to 0 and Y greater than or equal to 0. These are the two constraints. Let's go for the another one. X greater than 0 we have taken, Y greater than or equal to 0 we have taken, and this also must be greater than or equal to 0. That is transportation or the quantity which is transported from godown A to F. 100 minus of X plus Y greater than or equal to 0. When you calculate X plus Y, this will go to right side, that is less than or equal to 100. Then next constraint is 60 minus X, this one. 60 minus X must be greater than or equal to 0 because this is also a quantity. Here it is mentioned here. Quintals transported to each depot must be greater than or equal to 0. Means this is also a quantity which is transported from godown B to shop D. This also must be greater than or equal to 0. 60 minus X greater than or equal to 0. That means X less than or equal to 60. When you take this one to the right side, it becomes less than or equal to the symbol. So X less than or equal to 60. Then next one is 50 minus Y. That is 50 minus Y greater than or equal to 0. That is Y less than or equal to 50. Means there is a minus symbol along with the variable, so the inequality will change when it constant is taken to the right side. So Y less than or equal to 50. Finally, here X plus Y minus 60 greater than or equal to 0. That means X plus Y greater than or equal to 60. As we need to minimize the cost of transportation, that is our question. The transportation must be minimum, and the minimum cost of transportation we have to calculate. Means the function used to minimize is X, the total transportation cost will be, and this is a lengthy calculation, you must be very careful. Z is equal to 6 rupees X quintals transported, that is 6 into X. Then again 3 rupees per quintal Y quintals transported, that is 3Y, plus 2.50 into 100 minus X plus Y quintals transported, that is written, plus again from godown B 4 into 60 minus X, plus again from godown B 2 into 50 minus Y. 50 minus Y quintals transported, rupees 2 per quintal, that is 2 into 50 minus Y, plus finally from B to F, that is 3 rupees per quintal, we have transported X plus Y minus 60 quintals. So plus 3 into X plus Y minus 60. Take a sheet of paper and remove the bracket and go for the calculation, and after simplification you will get an equation Z is equal to 2.50x plus 1.50y plus 410. Please do not copy this one because the examination point of view it is very important, you must solve yourself. So take a sheet of paper and do the calculation, and finally you check that you are getting this equation. Here almost the things are ready. We need to minimize. Z is equal to 2.50x plus 1.50y plus 410. subject to constraints. We have to pick all these constraints and write together so that it will be easy for us to draw the graph. X plus y less than or equal to 100 is the first one. Here x greater less than or equal to 60, y less than or equal to 50, it's written. Then x plus y greater than or equal to 60. Again, the common constraints x comma y greater than or equal to 0. So we have to represent these many inequalities in the graph sheet and we have to find out the minimum cost. Next, let's plot the points on the graph. For that, just to make the table of values, first one x plus y is equal to 100. We have taken the equation. If you put x is equal to 0, y will be 100, and if you put y is equal to 0, x is 100. The table of values are ready. Next one is x plus y is equal to 60. For that x, y we have taken. If x is 0, y will be 60, and if you put 0, x plus 0 is equal to 60, that is x is equal to 60. These are the two inequalities we have to plot, and let's draw the graph. X-axis, y-axis we have plotted, marked, and just mark the x-axis and y-axis values 0 to 120 we have marked. And let's plot this graph first, that is x plus y greater than or equal to 60. That is what the inequality. Here we have formed the equation x plus y is equal to 60, and the table of values are here 0 60 0 60 is here, and the next is 60 0 60 0 is this one. So when you just plot it, the graph goes like this, and we have to find out the feasible region. For that I have taken this 0 0. If you put 0 0, 0 plus 0 is greater than or equal to 60. Inequality is greater, so 0 plus 0 is greater than 60, in the sense 0 is greater than 60. Means it is wrong. 0 is not greater than 60. That means this is not the feasible region. The opposite one is the feasible one. So that portion is marked, and x plus y greater than or equal to 60 is the region. Next, we will go with this one 0 100. 0 100 it is marked, and 100 0 is marked. And again we have to go for finding the feasible region. Again the same point we have to take 0 0. If you put 0 0, 0 plus 0, 0 plus 0 is less than 100. X plus y less than or equal to 100, that is what the inequality. So 0 plus 0 less than or equal to 100, that is a true statement. That means this portion is under feasible region. That means below the line is feasible one, and x plus y less than or equal to 100, that is the region that we have plotted here, that we have marked here. Next is y greater than or y less than or equal to 50. That is what the next inequality that we have to mark here, y less than or equal to 50. So y-axis 50 we have to take, and just to draw the line. Y less than 50, in the sense it is quite clear. Below the line is 50, less than 50. So below the line is 100 region. So y less than or equal to 50 we have marked. The next one is x-axis 60. X is equal to 60 we have marked, and x less than or equal to 60, that is what the inequality. Less than 60 in the sense left side of the line. So that is less than 60, and we have marked x less than or equal to 60. Now you can see there all the four inequalities are satisfying under this region. So that region we have to shade. Then we have to go for marking the corner points a 10 50. Here it is 10 and 50. Next is this point B is 50 50. That is, here you can see 50 and 50. And the next point is C 60 40. That is, here it is 60 and this is 40. And here it is D, that is 60 0. And let's go for finding out the minimum value. That is, corner points you have written first 10 50 50 50 60 40 and 60 0. All the points we have written in order. Then this is our minimizing equation, that is z is equal to 2.50 x plus 1.50 y plus 410. X and y value you have to put here, that is 2.50 into 10 plus 1.50 into 50 plus 410. When you add it, you will get 510. And here 50 50 you put it in the equation, you will get a 610. And 60 40 when you substitute here by replacing x and y, you will get 620. And 60 0 when you substitute in this equation by replacing x and y, you will get as 660. Please do not copy this one, and you have to go for substituting the value and just calculate it and write, so that it will be easy for you in the examination. Or else if you simply copy it, and you will not be get trained for the examination. So here we have to find out the minimum transportation cost. It means lower value we have to check. So the minimum value here is 510. So the minimum cost is 500, and now we have got the transportation cost is minimum at the point 1050. That means x is equal to 10, y is equal to 50. So in the previous slide, the visualization of the question was like this. So we have to replace x and y, and we have to substitute the values. So hence the transportation cost will be minimum if here this is go down A and go down B, shops D, E, F and all was there, and that was x quantity or x quintals transported from A to D. So x is equal to 10 we have got, because 1050 was the minimum value, or minimum value we are getting from the point 10 comma 50. So x is equal to 10. Then here we have got y quintals, that is y is equal to 50 we have substituted. Then here it is 100 minus x plus y, that when we do the calculation 100 minus 10 plus 50, so 100 minus 60, that is 40 quintals. And from here it was 60 minus x quintals, so that is 60 minus 10, that is 50 quintals. And from B to E, there is 50 minus y quintals, that is 50 minus 50, that is 0 quintals. And from B to F, there is 40 minus 100 minus x plus y, that is, or here it is x plus y minus 60, that is better. If you take the first one, there will be confusion. So this one we can take 10 plus 50 minus 60, that is equal to 0 quintals. And let's go for writing the conclusion. That is, minimum cost is rupees 510, and from A we have to transport 10, 50 and 40 quintals to shop D, E and F respectively. 10, 50 and 40 quintals that we have to transport from go down A. And from go down B, there is 50 quintals, 0 quintals and 0 quintals to shop D and E and F respectively. So this is our conclusion. Now move on to question number 7 from the miscellaneous exercise. An oil company has two depots A and B with capacities of 7,000 liters and 4,000 liters respectively. The company is to supply oil to 3 petrol pumps D, E and F whose requirements are 4,500 liters, 3,000 liters, 3,500 liters respectively. The distances in kilometer between the depots and the petrol pumps is given in the following table. So the distance in kilometer from or to A and B. So D to A or A to D, the distance is 7, and here it is 3, and A to E, that is 6, B to E, that is 4, A to F, that is 3 kilometer, and B to F, that is 2 kilometers. Here, assuming that the transportation cost of 10 liters of oil is rupees 1 per kilometer, how should the delivery be scheduled in order that the transportation cost is minimum? What is the minimum cost? And here once again let's go through the question. An oil company has two depots A and B, and just like the previous question only, A and B two depots are there. Previously it was go downs. Here A and B two depots, capacity is 7,000 liters and 4,000 liters respectively. The company is planning to supply the petrol pumps D, E and F. Requirements of D 4,500 liters, requirement to E, that is 3,000 liters, and requirement to F, that is 3,500 liters. Distances are given, and here there is a problem. Distance in kilometer, that is A to D distance is 7 kilometer, but the cost is given to you here. Cost of transportation is 10 liters of oil. For transporting 10 liters of oil, rupees 1. So we have to convert this all. For that, let's take the assumption first. Depot A transport X liters to petrol pump D, and depot A transport Y liters to petrol pump E. So by using this X and Y, like the previous question, we will connect the remaining depots and the petrol pumps. Now we have to convert this table. For that, let's write that one to or from D, E, F as it is written, and to A, that is 7, 6 and 3, A to D, that is 7, A to E, that is 6 kilometer, A to F, that is 3 kilometer. And here it is given to you 10 liters of oil is rupees 1 per kilometer. That we have to use for conversion. Before that, let's complete this one. B, B to D, the distance is 3, and B to E, the distance is 4, and B to F, the distance is 2 kilometers. But to go for finding the cost, A to D, cost from A to D is 7 into 0.1. 7 into 0.1 means here 10 liters of oil rupees 1. That means 1 liters of oil is 1 by 10. 1 by 10 is 0.1. So 7 into 0.1, that is 0.7 rupees. Then next is A to E, that is 6 into 0.1 because 6 kilometer. So per kilometer, per liter it is, sorry, per kilometer it is 0.1 rupees. So 6 into 0.1, that is 0.6. Next is A to F, that is 3 into 0.1, that is 0.3. Next is cost from B, that is B to D. B to D is 3 kilometers are there, that is 3 into 0.1, that is 0.3. Next is B to E, that is 4 into 0.1, that is 0.4. B to F, that is B to F is here 2. 2 into 0.1, that is 0.2. So this is the additional calculation, because there is condition is little bit of difference is there. 10 liters of oil is rupees 1. So 1 liters of oil is 1 by 10, that is 0.1. By using 0.1, we have calculated all these values. Now, like the previous question, let's visualize the given question by using the given conditions. There are two depots. Oil company has two depots, A and B, capacities of 7,000 and 4,000 liters. Depot A, depot B, it is mentioned. And that the company has to supply oil to 3 petrol pumps, D, E and F. So petrol pumps D, E and F, 4,500, 3,000 and 3,500 liters capacity that we have marked. Then go for our assumption. As per our assumption, X liters we have transported from depot A to petrol pump D, and Y liters we have transported from depot A to petrol pump E. And of course 7,000 liters is the capacity, and X liters gone to D and Y liters gone to E. The balance will come to F, that is 7,000 minus of X plus Y liters. And here again from depot D and B, the calculation just like the previous question. Requirement of petrol pump D is 4,500. X liters already got from A, so the balance it will come from B, that is 4,500 minus X, that is written. And for E, Y liters already got from A, 3,000 liters is the requirement, so balance, that is 3,000 minus Y liters will come from B. Then for F, 7,000 minus of X plus Y liters already got from A, the balance will come. This means the balance out of these 3,500, 7,000 minus of X plus Y got from depot A, the balance will come from depot B, that is 3,500 minus 7,000 minus of X plus Y. So when you go for the calculation, you will get as X plus Y minus 3,500 liters that we have got here. Then the cost of transportation, that we have to use this table and write, that is from depot A we have got 0.7, and next is 0.6 that is written, and next is 0.3 that we have written here. The next is 0.3 again, that is written, and D to E, that is 0.4 that is written, and here it is B to F, that is 0.2 that is written. Then since the number of liters transported to each depot must be greater than or equal to 0, that means X greater than or equal to 0, Y greater than or equal to 0. And we have to go for writing the constraints. The first one is 7,000 minus of X plus Y greater than or equal to 0. When you do the calculation, X plus Y less than or equal to 7,000. Since there is a minus sign, when it comes to the right side constant, it changes the inequality. So X plus Y less than or equal to 7,000. Next one is 4,500 minus X is greater than or equal to 0, because it should be a positive quantity. That is what it is written here, or equal to 0. So by using that, we can say the quantity, that is 4,500 minus X is greater than or equal to 0. That means X less than or equal to 4,500. And the next one is 3,000 minus Y greater than or equal to 0. That means Y less than or equal to 3,000. Then again X plus Y minus 3,500, that is greater than or equal to 0. And you go for calculation, X plus Y greater than or equal to 3,000. 500. Now, as we need to minimize the cost of transportation, just like the previous question, the cost of transportation, when you write the equation, you have to be a little bit careful. That is, the function used here is minimize is that total transportation cost is that is equal to x into 0.7, that is 0.7x plus 0.6y plus 0.3 into 7000 minus of x plus y plus 0.3 into 4500 minus x, then plus 0.4 into 3000 minus y plus 0.2 into 3000 minus 7000 minus of x plus y, that is x plus y minus 3500 that we have put here. Then when you go for the calculation, here I have explained the calculation. In the previous question I have not done that, so I was asked you to do. Here it is explained here. Anyway, please do not copy, just do the calculation by your own. So 0.7x plus 0.6y plus, when you multiply these two, it will come as 2100, then minus 0.3x, then here again minus 0.3y plus, then 0.3 into 4500, it is 1350 minus 0.3 into minus x, that is minus 0.3x, then plus 0.4 into 3000, that is 1200 minus 0.4 into y, 0.4y, then 0.2 into x, that is 0.2x, then 0.2 into y, 0.2y, then 0.2 into 3500, you will get as 700. And when you collect the like terms and go for the calculation, you will get as 0.3x plus 0.1y plus 3950. This much calculation you have to do it yourself without referring here. So let's go for writing the conclusion. So we have to minimize z is equal to 0.3x plus 0.1y plus 3950 subject to constraints. Write all the constraints or inequalities together. X plus y less than or equal to 7000, y less than or equal to 3500, x less than or equal to 4500, x plus y greater than or equal to 3500, and finally x comma y greater than or equal to 0. So all these inequalities are here. As before, you have to take a graph sheet and plot these equations first, then you have to go for shading the common feasible region and find out the minimum cost. So this you have to do it as homework. Dear students, today we have learned how to solve the transportation problems by using linear programming. Hope it is clear for you all. If you have any doubt while solving, please note it and keep, and we will discuss it during the discussion session. Thank you for watching.